Hey, what's going on, guys? Let's try this problem right here. This question is asking two sources of light illuminate a double slit simultaneously. One has wavelength 574.3 nanometer and the second has an unknown wavelength. The m is equal to 3 bright fringe of the unknown wavelength overlaps the m is equal to 3 bright fringe of the light of the known wavelength. What is the unknown wavelength? So let's call lambda is known wavelength, that is 574.3, and unknown wavelength is the question, right? And since we are dealing with fringes and double slit experiment, we can use Bragg's equation for this question, that is given by n lambda is equal to d sine theta, right? And here we don't have any angle, but this sine theta can be written as y over L. Here the y value is the distance between the bands of the light and the central maximum, and L is representing the distance from the slits to the screen from the center point. Now let's go ahead and replace this value, this one, with this one. So this is going to be n lambda is equal to d times y over L, and here we have n that's provided, that is where m represents, right? And for both of them n values equal. For the known and unknown we have n same value, right? And it's also mentioned right here, for the known one it's m is equal to 3, for the unknown one m is equal to 3. So first we are dealing with the known one and see what we can get from that. And for the known one we have this one, n is equal to 3 and lambda is 574.3, and then that is equivalent to d, we don't have that one, and y also we don't have, and L also we don't have. So three unknowns are here, but the best thing we can do is we can rearrange this one in terms of y and plug it in the second equation. Y is going to be equivalent to 3 times, I'm going to keep this 3, I'm not going to multiply, because if you notice the second one also has the same 3, so it might cancel each other. So it's better not to multiply and keep it as it is, so it will cancel in the second one, right? So 574.3, and then that is multiplied by L divided by D, right? So this is the y value for the first one. Now let's deal with the second unknown wavelength. It's going to be the same equation. Now let's rearrange this equation. So this is going to be lambda is equal to d over n y over L. Okay, and we found out y is this one. Y is 3 times, so let's write this one first, d over n value is 3. For this one also d is unknown, but it's going to be same as the previous one, because they are saying two sources of light illuminate double slits simultaneously. So we are dealing with the same double slit. So this is going to be d over 3, and then y is going to be 3 times 574.3 times L divided by D. I just replace the y value with this one, and also we have a L in the bottom, so I just put it right here. And from this one you can see all of them cancels. This D cancels, this L cancels, this 3 cancels, so we get the same answer. So for the second wavelength also going to be 574.3 nanometer, and that's the answer for the first one. Now let's look at the second one. At most, how many bright fringes can be formed on one side of the central bright fringe, not counting the central bright fringe, when light of 618 nanometer falls on a double slit whose spacing is 1.85 times 10 to the power of minus 6 meter. Now let's see. Again we can use the same equation, n lambda is equal to d sine theta, and here what we are trying to find is, we are trying to find this n value. N is equal to d sine theta over lambda, and now when sine is maximum it's going to be just 1, so we can put 1 right here, and d is the separation, slit separation, that is 1.85 times 10 to the power of minus 6, 85 times 10 to the power minus 6 meter, and sine theta is going to be 1 at maximum, and then lambda is going to be this one, 618 times 10 to the power of minus 9 meter, and if you calculate this one you should get 2.9935, and that is approximately 3. So 3 is going to be the answer. So 3 bright fringes will be formed. I hope this helps. Thanks for watching.